Example here of a piecewise defined function. So when we have this function and it says, is that f of x equals, and so we're looking at, this is section 1.4. So sometimes this function equals x plus 5. Sometimes this function equals the square root of 9 minus x squared. And sometimes this function equals negative x plus 5. Okay? This is called a piecewise defined function. And what they do over here is they list different pieces of the domain, different intervals of the domain. So it tells me, okay, when x is less than or equal to negative 3, I'm looking at that. When x is between negative 3 and 3, I'm looking at that. And when x is bigger than 3, I look at this for an output. And this is a really nice intro exercise to learning what this means, okay? So one of the first things they ask me is they say, let me find f of negative 4. I want to ask you, which line am I on? In other words, here's line 1, here's line 2, here's line 3. Which line should I use? This line 1, this x plus 5, right? So because negative 4 is smaller than negative 3, we're going to use f of x equals x plus 5 to figure this one out. So I get, let's see, negative 4 plus 5, I get positive 1. But another problem they had me do, for example, was they had me do f of 3. Oh, I'll tell you what, I'm missing something here. What page is this on? 65. I got to check. Because I don't know which line I'm supposed to be on when I input 3. I don't know. It doesn't say the way it's written there, so let's just double check. Go to the actual problem. Oh, thanks. There it is. No? 63? Oh, at the bottom. Thank you. Let's see it there. Okay, so here's my error, is that if you look at the function, the middle one has when we're less than or equal to 3, right? And the bottom one is only when we're greater than 3. So going back to this, I need to make a correction. I need to make this less than or equal to 3. Okay? And so f of 3, well, here we're going to be using f of x is the square root of 9 minus x squared. And so I get the square root of 9 minus 3 squared, which is the square root of 9 minus 9, which is 0. Okay? So this is the first example I've had of a function whose output can vary. But we actually use that a lot in everyday life. You don't always get the same kind of output. Sometimes it depends what the input is. And we'll make a decision. Okay? Say at the computer sometimes. And they give the example here for rocket, which is another piecewise. Another math example I like to use for this kind of one. Here's a function that I think you'll be familiar with. I'm not sure if you know what the graph looks like or not, but let's try this. Let's try, we'll call it a of x is, do you know what that symbol is, those bars right there? That's the absolute value of x. Oh yeah, we talked about that. What does that mean? It's the distance from 0, and it could be plus or minus whatever the input is. So let's try to sketch a graph. Actually, let's plot a few inputs. So if I put in a 1, what's a of 1? No, it's just 1. Absolute value is distance. Distance is always positive. If I input 1, the output is 1. What if I input 2? How far away from 0 is 2? Sure. What if I input negative 2? That's also 2 away from 0. If I input negative 1, that's 1. And if I input 0, that's 0. And I think a good exercise right now is to very quickly try to sketch a graph. Maybe you could plot these points and see if you can graph what the whole function would look like. 1 comma 1 is a point, but also like take this line here or this line here. Negative 1 comma 1 is a point, and negative 2 comma 2 is a point, right? And so, do you see what I mean about a V? 0, 0's here. And could I put these arrows to say that that goes on indefinitely? Yeah. Okay. Now let's talk a little bit about some of the ideas we've learned so far with my new function. Let's talk about the domain. What's the domain for the absolute value function? Are you allowed to take the absolute value of anything on the real line? Why not, right? So the domain, I guess, would be from negative infinity to positive infinity, all real numbers. While I'm at it, why don't I talk about the range of the absolute value function? What's the set of all possible outputs? Now I want to look on the y-axis, and I want to say, well, what numbers are we going to hit on the y-axis if we project? And you probably know, don't you? Yep. 0 to infinity. Right? Will we ever get an output that's negative? No. Okay, so there's nice talk about domain and range. Now it turns out then, once you see this, there's another way to write the absolute value function without using that symbol. And actually, this is going to be very helpful in future classes if you have to study this. I think even in this class we're going to get to it eventually. Another way to write the absolute value function is as a piecewise function. Because it behaves differently when the input is positive or equal to 0, or when the input is less than 0. I mean, take a look at the first two I did. 1, 1, 2, 2, 15, 15, all those positive numbers. Basically, isn't the input and the output exactly the same? So for that, I would say that a of x just equals whatever x is. You follow me? But I would not want to put that down here, or I'd be wrong. What do I want to put down there? The opposite of x, right? Because if you input a negative number, you go down here, and this says we'll take the opposite of that, and the output then is going to be what? Positive. This is a nice example of a piecewise defined function that we're very familiar with. We use absolute values all the time because we want to talk about distances. And distances are always positive. Hey, how far is it from here to my house at home? 20 miles. Well, what if I go the other way? Is it negative 20? No, I'm sorry. It's 20 miles, right? So that's the deal. You guys follow? Are there any other questions about number 35?